Welcome to our entry on the Pythagorean Theorem. You should have watched the introduction video, so you should be familiar with a little bit about this theorem, and now we're just going to put it into work with these two pieces of paper you should have. So there's this Pythagorean Theorem two-sided worksheet that we're actually going to make a foldable into. It's going to fold in and in just like that. So we've got the Pythagorean Theorem on the front with some fill in the blanks. The back is where we're going to glue or tape in to our notebooks. And on the side I've got some vocabulary that I've already filled out just to save some time. So what I'm going to have you do is you're going to start with a worksheet just like this. And then you're going to fold this one in, so it's about a third of the way. And then this one, so it covers the rest. Okay? And if you need help folding, just call your teacher over and they can help you. Secondly, what I'm going to ask you to do is kind of just write in the vocabulary as I'm talking about it. That way you'll be all set when we start doing the examples. So these things you should already be familiar with. A right triangle is a triangle with a 90-degree angle. Legs. So when you look at a triangle, the legs are the shorter sides of a right triangle. So if you have a right triangle here, the legs are going to be these shorter sides. The hypotenuse is the side opposite the right angle. So you can see this is our 90-degree angle, our right angle. So the side opposite is going to be the hypotenuse. And then we have the square root symbol, which is the opposite of squaring something. So if we do 2 squared, we get 4. Well, if we want to do the opposite, we would take the square root of 4 and it would bring us back to 2. So squaring something and taking the square root of something are opposite operations. And then we have symbols that you'll definitely need to know once we get to geometry, and you should be familiar with these already. This symbol is like the L, but the top of the L is kind of bent in. It stands for an angle. So for example, if we were talking about angle A, we'd make that little angle symbol and we'd denote it as A, or angle B. A right angle just means it's got a box at the angle that's 90 degrees to show that it's a 90-degree angle. If you have a triangle that does not have that box and it doesn't say that it's a right triangle, you can't assume that it's a right triangle. They either have to say it in the problem or they have to show the box. Otherwise you can't assume. We have the triangle symbol. So when you're talking about a triangle and you want to talk about a specific triangle, you would say triangle ABC. And then we have the square root symbol, which you should be familiar with after our radicals entry, where the radical symbol is here and the index is 2. So that's it for the vocabulary. So taking a look at the front of our foldable, once we folded it into a pamphlet, we have the Pythagorean Theorem with this fill-in-the-blank triangle. And so what we're going to do is we're going to fill these in with the vocab that we just learned. So in general, when you have a right triangle, they're usually going to use the letters A, B, and C to denote the sides. And A is usually going to be the side, or one of the legs. B is going to be the other leg. It doesn't matter if this is B and this is A. But in general, C is usually the hypotenuse. So yes, they could use other letters, but in general, usually it's A, B, and then C. So A denotes this length here, and this is called a leg, if you remember from the vocab. B is another leg, and C, which is the side that's opposite the right angle, is called the hypotenuse. Alright, now we're going to get down to what the Pythagorean theorem really is. So, Pythagoras was one of the people that came up with the Pythagorean Theorem. He wasn't the only one, but he's usually the one that gets credit for it. And what it is this. If you have a length A and a length B, and you're looking for length C, okay, you don't need to measure this one if you know the measures of these two. Okay, so what they found out is that if you square A and then you square B, when you add those squares together, you should get the square of C. And how that looks in a problem is if we square both of these legs, A squared plus B squared we should get C squared. Okay? And so when we start thinking about why this theorem works, is what they did is they actually made a square. They made a square coming off of here. So let me move down. A square coming off of A, and then a square coming off of B. And they realized that when they added those areas together of those squares, it equaled the area of a square coming out of C. And so there are different ways to prove the theorem. And for a while, it took a while for them to actually find a proof for it. But then once they found one, they started to find others, and I think there's at least 3 or 4 proofs of the theorem. And you're going to do one of them in the activities that follows these notes. So we have the outline of the Pythagorean Theorem, and you're going to put your name in. Mine's going to be Mr. Willett. You're not going to write Mr. Willett, you're going to write your own name. And then we'll open this up and we'll get started with actually using the Pythagorean Theorem. So now we're going to open that up and we're going to work on problem 1. So they're asking, is it a right triangle? So according to the Pythagorean Theorem, A squared plus B squared should equal C squared. That means when I square A, which would be 25, 5 squared is 25, and I add the square of B, and 12 squared is 144, I should get the square of C, and 13 squared is 169. So let's see if that checks out. If I add 25 and 144, do I get 169? In fact, I do. So this one would be a right triangle. And let's try number 2 and see if number 2 works out. So 7 squared is 49. 8 squared would be 64. And when I add those together, would I get 144? If right off the bat I can see that when I add 4 and 9, that would give me a 3 in the ones digit, right? Which is not a 4 in the ones digit. So I know right away that that's not going to work. If you wanted to do the math out, you could also do that. But in fact, 49 plus 64 is not going to be 144. So the answer to this one would be no. Because when I do A squared plus B squared and it doesn't equal C squared, it can't be a right triangle. Now I want you to use the same process for number 3 and number 4. And before you move on, I want you to have your teacher check your answers. For number 5, I'm trying to find the length of the hypotenuse. So again, the hypotenuse is the line that is opposite the right angle. And what I want you to do is make sure that these are both in meters. There's a typo there. This would be meters, meters. Okay, because we're not going to do any unit conversions. That would be, this is a little bit too confusing. So, we're asked to find the length of the hypotenuse, C. Right? We know that it's a right triangle, so I know that the Pythagorean theorem should hold true. That a squared plus b squared should give me c squared. And I just have to fill in for a, b, and find c. Now, like I said in the beginning, it doesn't matter which one you call a, which one you call b, okay? As long as you don't use these ones as c, because c is very, very definitively the one across from the hypotenuse. So let's fill these in. I'm going to call this one a and this one b. So I've got 12 squared plus 35 squared should give me c squared. And 12 squared is 144 plus 35 squared is 1,225, and that should equal c squared, because I don't know this length yet, but I know that the Pythagorean theorem holds true, and that when I add these two together it should get c squared. And now I simplify. 144 plus 1,225 is 1,369, should equal c squared. And now, if I know that c squared is 1,369, and I want to solve for c, I have to start doing opposite operations to get c by itself. Now, a common error is to divide by 2, but dividing by 2 isn't really the opposite of squaring something. The opposite of squaring something is taking the square root. So we have to take the square root of both sides. So the square root of c squared, because those two are opposites, it's just going to be c. And the square root of 1,369 is going to equal 37. So c equals 37, and then don't forget we're in meters. So a bit more of a process for that one, but again, it's just math. We're just substituting in and then solving an equation, so it's almost just like Unit 1. We just have some exponents to work with now. Your goal is to do number 6 on your own, and then have your teacher check your answers. So you probably guess what the next step's going to be. We've had to determine whether or not something is a right triangle by seeing if the Pythagorean theorem is true. We've had to, given that a triangle is a right triangle, find the hypotenuse. Really the only other information we would have to do, or something else that we would be asked, is to find a leg, given that it's a right triangle. Right? Because you're either going to be finding this leg, or you're going to be finding a hypotenuse. You're not really going to be asked to find both until you get to geometry or possibly pre-calculus. Here for number 7, we have an A, a B, and a C. So I can label them so that when I start putting them into my Pythagorean theorem, I can find the length of the leg. Now, it would be interesting if you were given this question and they didn't say that it's a right triangle. The solution to finding the leg would actually be there's not enough information, because for the math that you know right now, for Algebra 1, you wouldn't have enough information to find this leg, okay, without knowing that that is a right triangle. So if they don't either say, solve the length of a leg of the right triangle, or they don't put in this 90-degree symbol, you can't say that you can use the Pythagorean theorem. You would simply say, I don't have enough information. In this case we do, right, because we have that symbol. So we're going to substitute in what we know. Here we know that A is 28, so 28 squared. B, we don't know, so we're going to leave it as b squared. And c we know as 35, so 35 squared. And now we're going to simplify. 28 squared is 784, plus b squared, there's nothing we can do with that yet, and 35 squared is 1,225. Now, I need to find b, so I have to start doing opposite operations to get b by itself. And I can't immediately take the square root of both sides, because I need to get rid of this 784 first. So my step really here is going to be to subtract 784 from both sides. So taking a look at the front of our foldable, once we folded it into a pamphlet, we have the Pythagorean Theorem with this fill-in-the-blank triangle. And so what we're going to do is we're going to fill these in with the vocab that we just learned. So in general, when you have a right triangle, they're usually going to use the letters A, B, and C to denote the sides. And A is usually going to be the side, or one of the legs. B is going to be the other leg. It doesn't matter if this is B and this is A. But in general, C is usually the hypotenuse. So yes, they could use other letters, but in general, usually it's A, B, and then C. So A denotes this length here, and this is called a leg, if you remember from the vocab. B is another leg, and C, which is the side that's opposite the right angle, is called the hypotenuse. And now that you have your completed foldable here, you're going to put a piece of tape along the top, a piece of tape along the bottom, just of the middle section, and then that will be taped into your entry. Or if you just have a glue stick, you can put glue on the back, or even just a dot of glue on the corners of that middle fold, and then glue it in that way. In your packet, you've also received these three problems. Okay, you're going to cut these out. These are going to be your practice problems on the left side. You've got number 1, number 2, and finally number 3. And then you're done. The next step after you have this checked by your teacher is going to be to work on the 10.3 packet for Pythagorean Theorem, which is a proof of Pythagorean Theorem, as well as using it more in practice.